and welcome everyone to CSC Core Concepts in my series of machine learning algorithms with implementation in RStudio. In this video, I am going to explain and demonstrate you about a very popular algorithm called as the Boruta algorithm, which is basically a feature selection algorithm. So when we were discussing about the dimensionality reduction techniques, so we have seen that dimensionality reduction techniques are categorized as either feature selection or feature extraction. So as far as feature extraction is concerned, we will deal with it in the some other video. Right now, I will tell you how to select some features which are the important features for your model using the Boruta algorithm. So basically, it uses the random forest classifier, and with every step, it is going to find out the most important features. So basically, the name Boruta is derived from the name of a demon, which was in a Slavic mythology who used to live or dwell in the pine forest. Okay. So let us start with it. That first of all, the Boruta algorithm is going to you have the original data set. So this algorithm will create randomness in your data set by creating a shadow copies of each of the features. Understood? So it will create a shuffled copies, not in the same order set, but in a shuffled copy. Now, if you remember the random forest classifier, so basically it is going to create many decision trees, right? So the number of decision trees it will create will be maximum will more, and in each decision tree it generates a different set of it tests with a different set of attributes, right? This is what the random forest classifier does. So basically here also it is going to do the same with the shadow attributes, and it is going to compute something called as the mean decrease accuracy, and a higher mean value means that the feature is very important. Okay, so if the mean is less, so that means that feature is not at all important, right? So at every step, since it is a wrapper algorithm, so it is going to perform a number of iterations. So every real feature has a higher importance than the shadow features. This is going to be compared using a statistical measure called as the z-score. So higher z-score than the maximum z-score of the shadow features means that the real feature has more importance than its shadow features, and as and when it is going to get the important features, it is going to remove the other features, unimportant features, right? Which it is saying that it is not important at all. And finally, the algorithm will stop either here all of the features get confirmed that yes, these are all the important features and these are unimportant, and you reject the unimportant ones. Or let's say if you have written in your algorithm or your demonstration that maximum random forest to be applied is, let's say, 10 times. So if it has reached 10 times the limit, up to that time whatever important features it could derive, it will tell you, right? So what you have to do here is that you create a random forest model based on the data, and it will recursively get rid of the features in every iteration which are not important at all, and hence slowly in every iteration the number of subset of the set of features will decrease, and only those features will be kept which are of more important to you. Okay, so this is going to be performed in the Boruta algorithm. So let us do one thing. Let us start the demonstration of the Boruta algorithm. Now I would like to perform this on a data set which is a loan prediction data set. Now whether to give a loan, whether to grant a loan to a person or not, that depends on many parameters. Let's say the gender, whether he is married or not, how many dependents he has, what is his education level, whether he is self-employed or not, then whether the income capacity, then co-applicant's income. Okay, if two people are applying, then what is the co-applicant's income? How much amount of loan he wants? Okay, so loan amount he requires, and how much amount? Yeah, so terms, right? Like for how many days he wants the loan, his credit history, that how good he has been earlier, if he has taken any loan or not, and whether he has repaid them timely, and his property area, where he has some property, like whether he is in a he's staying in a semi-urban area or a rural area or an urban area. So there, that depends, that will decide whether he has to be given a loan or not. Okay. So let's say for get started by including some of the library packages. So we are going to apply the Boruta algorithm. So obviously Boruta package we have to add. Then library, ML bench, some more library files we will require here. Then obviously for prediction and decision, when you are using the random forest, you require the carrot library, and you require the random forest also, right? Fine. So let us include all these library files in our package, and when we are done, we can read the data. So let's give the name of the data as my data is read.csv. Let's say it is, so the name of the file is loan prediction train. Just a minute. Yeah. Yeah, so loan prediction train.csv. Let's see the structure of the data. Let's see the structure of the data, whether we need to convert anything. Okay, so this is the structure of the data. You can see many of them are the character type variables. Applicant income is integer. It is very unorganized structure, and especially the loan status is character, which we want as a classification, right? So whether it should be either yes or no. So if you can see the summary of your data, that also you can see. Let's see, and then we will change it to factor variable. Now the summary of the data will tell you each data, how many, what is the character and what is the mode, right? Whether it is character type and maximum, like suppose if it is a numeric data, then what is the minimum value, what is the median value, what is the maximum value, that's it. Okay, so this is another way of viewing the data. And let's say we can see here, yeah, so if you see in that data, let's go again, we can see there are many blank spaces, right? So that is not applicable, so we have to remove this, right? Because it will confuse your model. So what we can do is that my data, in case if you are getting such type of problems, so you have to complete cases my data. Okay, so now if you view your data, let's see, if you view your data, see, we can see here we had this loan amount, the first value, so it is going to create, right? It is generating some data. It is not like it, either it can make a zero value, right? Or it can give some value. Now see, this is a different type of topic which I would not want to divert here in YouTube in this video. Now the thing is that, see, whenever you have some missing data, there are various techniques of filling up the data, right? So you cannot randomly give any data, right? So now in that case, sometimes you compute the average value of that whole column. Sometimes you fill it with the median value. Sometimes if you are giving zero, now zero has a significance, right? Zero is a value, right? If you are saying applicant's income is zero, then it will make a drastic effect on the results, right? So you cannot simply give zero. So there are different types of things which are there and which can be you have to use it in order to set your data, right? Maybe in my some upcoming videos, we will discuss about how to fill up the missing values. Okay. So anyway, here we had seen that basically our last, that is the loan status was character type, character yes or no, right? So we have to convert it into categorical because it is a decision data. So my data, the field name is what? Loan status. Uh, Loan status is equals to, it should be a factor variable. Okay, we want it to convert it into a factor variable because it is a categorical type. Yeah, so my data, it has been converted. We can see the structure of the data again. So now it has been converted into a factor variable of 2 times. Now again we have to split the data. So let's say sample data SD is equals to sample. There are two splits we want for the number of rows of my data. Okay, and replace is equals to t, and let's say the splitting we want to do as 70-30, let's say. So 70% will be your training data and 30% will be your testing data. So let's say train data is equals to my data. The first sample will belong to, the first part will belong to the training data set, and your test data is equals to my data is d is equals to 2. So let's see how many data we had. We had 529 observations total. So 369 went into training data sample and 160 is your testing data sample. Now let us go with the Boruta algorithm. So let's say the Boruta is equals to, this is our package Boruta, uh, that is loan status. This is what you want to find out. Okay, so we do not know right now that which features are important, so let me do it with all the features. Okay, just accept the first one. If you see, the first one was what? Loan ID. ID is not, will not contribute to the model performance. Okay, so we will just say minus loan ID, the first one. And your data, sorry, yeah. So your data is equals to train data. Okay, let's just apply Boruta. So it is getting done. So if I want to see Boruta, let's say I want to print it. So it is taking lot of time. So you can imagine that so many random forest has been created, and of course we had 13 variables minus loan ID means let's say 12 variables. So it is doing the work. So it is done. So if I want to see Boruta, how does it performed, uh, then you will have a problem here. That is, yeah. So it performed 99 iterations, right? How many iterations it performed? 99 in 7.601258 seconds. 6 attributes confirmed important. Okay, how many are important? Applicant income, co-applicant's income, credit history, loan amount term and loan amount, and one more. Okay, so these attributes were termed as important, and it makes sense also. Attributes confirmed unimportant is education, married, and self-employed, right? These are tentative are two. Tentative means you can consider it important, you may leave it also. Dependence and the gender, right? These are the tentative attributes. So this is what it is being shown in the Boruta algorithm. Now if you want to plot, let's see if I want to plot Boruta. is equals to 2 and axis is equals to up to 0.7 if I want to go. Okay. Let's see the plot. Yeah, the importance value you can see here. So this is the shadow of the values. Okay, because it will create the shadow variables, right? Shadow max, shadow self-employed. So it is showing you the level of importance. So self-employed is not that much. Education is not that much. Dependence was a tentative attribute. Gender was a tentative attribute. But with green, they are the important ones. That is the property area, loan amount term, applicant's income, loan amount, co-applicant's income, and the credit history as the maximum. Like, see, if you are a defaulter, obviously they will not give you loan, whatever is your income, right? So this is the plot. Now, if you want to see plot, if I want to just see the plot, important history of Boruta. So here you can have a graph, right? This way also you can see the importance. And if you want to, okay, let us now do one thing. Tentative attributes if you want to see, right? So you have different functions here. Let's say Boruta is equals to tentative rough fix. Boruta, you can see here. Let's see. Boruta performed 99 attributes. So Sri, okay, you are not considering the tentative ones. Okay, only the important and the unimportant ones. It is also considered. See, you have fixed it. So here it has considered them as also important ones. I told you, tentative attributes are those attributes which you may consider also, right? Now, the attributes you know. Fine, you have understood what are the attributes which are important. Now you have to create your model. So the model will be created using what? Random forest. So let us see, do one thing. Let us create a random forest considering all the attributes, right? And then we will create using only the important ones so that you can understand. So loan attributes against all except the loan ID. Yeah, that is not required. And data is equals to train data. So if you are creating the random forest classifier using all attributes, and let's see the random forest using all. So this is the confusion matrix which is being created. I hope you remember random forest. If you don't, please go through my earlier videos. So the number of variables tried at each split is 3. The number of trees created is 500. Out of bag error is 19.51. So how many are correctly classified? 48 plus 241. Okay, so classification error is that is 55% in no category and 4% in the your yes category. That's it. Okay, so this is the so mostly the yes ones are corrected, are predicted correctly. No ones are predicted wrongly. That's fine. So this is considering all the attributes. So why it is getting less? Because see, sometimes what happens is that your model is getting confused because of the unimportant attributes, right? So if you want to see the classification accuracy, so you can do the prediction using the complete model RF all and the test data. You train the model considering all the attributes, right? So you can just see the predictions, how it is performing using the test data. So you can create the confusion matrix. So confusion matrix for P, and the test data is your test data's loan status. You can create the confusion matrix for this. Okay. So you can see the confusion matrix here, that is the accuracy is 84%. 95 confidence interval is 77 to 89%. This is the value, kappa value, and all values are given. Okay, so you are getting the accuracy 84% considering all the attributes. Now you can recall the random forest using only the important attributes which you have listed through the Boruta algorithm. So you can create random forest, that is lone status, not against all, but this time application. We need to refer to all the attributes. So let's see, applicant income plus co-applicant income plus, yeah, whatever attributes you want to add, you can add in this way. Okay, loan amount plus credit history plus property area plus okay, that's enough. Let's say, and data is equals to train data. Okay, only using the attributes, your important ones. Okay, so let us call the Boruta, RF Boruta, the random forest. So trees is 500 and splits is 2. So this is your error, right? So again here also same. So you can perform the prediction. Let us see using the test data. So P is equals to predict RF Boruta test data. So let us create the confusion matrix. Confusion matrix. Now this year accuracy is 83%. Okay, so because you have not considered the tentative, now you can consider the tentative also. Okay, and you can check it, because tentative we have completely ignored them. It cannot be, right? Sometimes they are also contributing. They are not ruling out. We are not completely ruling out that tentatives are not at all important, right? So you can even consider the tentative attributes, that is whether he is married and gender plus self-employed. So you can just check out on this, okay, how it is going to work with the random attributes, tentative attributes, understood? So, right. So here you can see 85%. So accuracy has increased, okay, as compared to all, right? All was giving you some 84% accuracy. Of course, it is very less. The increase is quite less, right? But this is how you can perform. Now here we are talking only about 12 attributes. Now you can have 1200 attributes, right? So when you have so many attributes, then of course this model will give you a good amount of subset of the attributes using which you can execute. Okay, so just you removed all the unimportant ones, right? So that has obviously contributed. So this is about your Boruta algorithm. I hope you understood it. So please don't forget to like, share and subscribe to CSE Core Concepts. Thank you.